We're going to look here today at why vegetation can dry out in a landscape. And we're going to look at a couple of things, how beavers can actually help the vegetation stay hydrated year-round, even into the dry season. We're going to look at how having richer soil can help the vegetation stay hydrated year-round. And we're also going to look at how the dams in the modern farming system actually leads to vegetation dying out in the landscape. So in this first picture here, what we have is a diagram, and on this y-axis we have a picture of the ocean here, and as you go up this axis, it's going inland. So it's almost like you can imagine yourself looking down from a plane or something at the land, the ocean here in the inland. And then here is the time axis. So what happens here at A is it's the air with water vapor at ocean. So that it starts out here, and then B is where it starts to get clouds and rain, and C is where the river flows back out to the ocean. So the water vapor evaporates here at the ocean here, and then it blows inland to B, where it forms a cloud and forms rain. And then it begins to form a river, and the river flows out. And so this is during wet season, and during dry season there's no amount of water vapor that's going to create some clouds, and so until the next dry season. And then what happens is the water vapor comes in again, forms clouds, and then there's a river. So this is a very simple schematic diagram of what's happening on the land masses, with this basically this axis of the axis of inland, and then so it's just kind of imagining almost like a one-dimensional landscape, and then time, and we're seeing how it evolves. And so we can see here that where there's some water, there's a vegetation, and let's say the vegetation can grow for another four time periods, if each of these is one time period. And so it will survive for another 4 periods, and then it's going to die out because there's no water here at the next stage. So now we're going to look at what happens if there's beavers in the landscape. So what we have here is again this inland axis and then the time axis. In this case, the water comes inland, and then it forms a cloud, rains, and then it forms a river. And then a beaver will come along and it actually creates a wetland. So these little dashed line is a wetland. So some of it, the water continues flowing out to the river, back to the ocean. But some of it actually goes into the wetlands. And then the wetlands, it will slowly leak out through the soil, and it'll flow out through the soil. And at some point, maybe it forms a river again. So this is happening all through the dry season. And then at the next wet season, the water comes in and it forms a river, and the river splits into the wetlands and to the river. But now let's look at the vegetation. So there's a vegetation here, there's water, and it can survive 4 steps. And so it actually, here you can actually see there's water coming down from the soil, so it actually hits the vegetation again. So it can again survive until the next river. And so in this case, we can see that the beavers have done something to the water system by slowing it down. So it actually allows vegetation to grow year-round instead of drying out and dying. And this has implications for all sorts of things. For instance, if it's drying out, it's going to be a lot more vulnerable to wildfires. And so you could see here that having beavers in the landscape can actually stop wildfires from happening. Now we're going to take a look here at when there's not so rich soil, and we're going to actually introduce evapotranspiration into the equation. In the previous maps we didn't quite look at that. So again, we have this axis of going inland and the time axis here, and the water comes in, it forms a cloud, and then it starts flowing through the soil, gets to the river, and then it flows out again. And then the vegetation here, it survives for 4 steps and then it dies out. So into the dry season, the vegetation gets all dry, becomes vulnerable to wildfires. Now, let's have richer soil. What happens? So the water comes in from the ocean, forms a cloud, and starts moving through the landscape, through the soil. And then, because the soil is actually more hydrated, and sits in the soil longer, it can actually then, it has more chances of evapotranspiring instead of just becoming runoff through the river. And so this is actually catches the wind and actually gets blown further inland, and then maybe it gets blown back out towards the ocean a bit again, and then it forms a cloud, and here it becomes soil, and then it maybe gets blown. It just sits in the air, goes straight up, and then it forms soil again, and then some other of the when it's through the soil keeps flowing down the soil, and then it can perhaps evapotranspire again and form another wind pattern where it forms a cloud and then comes back down. And so it can kind of, the water starts spreading out throughout the landscape. And then this is the next wet season where it comes in again. But you can see here now with vegetation, because there's water moving throughout the landscape, the vegetation gets to here, but it actually gets some of the water flowing through the soil, so it actually can keep surviving. So in this case, we see that the water has, the vegetation has kept surviving throughout. So now we're going to look at another case. In this case, we're going to look at what happens with the modern farming system, with dams and aqueducts and modern farms, and why it actually doesn't quite work as well for keeping vegetation. So we have the inland axis and the time axis, and the water comes in from the ocean, forms a cloud, goes to the river, and then catches in the dam. So these are square dots of the dam. So it just stays in the dam. And then what happens is that in the modern farming system, it gets channeled through the aqueducts to the farm. The farm is right here, and there's vegetation growing here, and then it's runoff. What happens in the farms is they put irrigation pipes in the soil, and then they just drain it back out to the rivers. So it doesn't really stay in the landscape very long. So you can see here, then it constantly has to be funneled down to the farms from the dams, and so it's kind of like it's almost like, well, it is human control through the aqueduct system to regularly give inputs to the farm. And so along here the vegetation will keep growing, and then the water will keep. But you can see here, when it was moving through the aqueducts along this path, there is no water in the landscape, so none of the vegetation here can survive. So let's imagine, instead of having dams in the system, we actually have wetlands in the system to catch the rainwater. And the wetlands are a bit more decentralized because they're all over the different places. So the water vapor comes in, forms a cloud, forms these rivers, and then some of it gets caught in the wetland. And then in the wetland it can evapotranspire, get blown around, and then move through the soil. Or some other parts of it from this wetland may seep into the soil and then go into a river and then get blown out. And so there's all sorts of different paths for the water in this kind of landscape, the more decentralized wetland landscape. And we can see here that we have actually vegetation growing along here, which is where the farm was, but also at other places, because they also have water throughout the landscape, we actually have vegetation here at all these different levels. So here in the case with the modern factory farming dam aqueduct system, we only have crops growing where the farms are, whereas in this system where the water distributed, instead of being all kept in the dam, it's actually distributed throughout the whole landscape, and so much more trees and plants can grow. And also, because that's happening, it's actually increasing the amount of soil. So the amount of soil in the landscape is also constantly increasing in this case, which then allows even more vegetation to grow in the future.